So good day. Today we will continue to talk about possible constructions of aeronautical aircraft AC generators. As you probably remember from the previous times, you know that rotating field and rotating armature AC generators has a weak side is that they have brushes and slip rings. And these brushes and slip rings require regular maintenance, so we have to check residual length, we have to check surface of the slip rings, and these inspection intervals are not so great, so several thousands of flight hours only. So this problem can be overcome by means of brushless AC generator. In the front of you we have a very old brushless AC generator with air cooling. So what kinds of solutions do we have here? First of all, brushless AC generator has three machines inside. These are main generator, primary exciter, and pilot exciter. Of course, we also have to build in rotating rectifier. Also, we can see it on the stator. So main generator part, primary exciter part, as well as pilot exciter part. So how does it work? In the rotor of a main generator we have field windings. These field windings are wounded, wounded like this across poles of the rotor. This winding here is cut it out. These are in a good condition. So these windings are connected in series to each other. But further, we have to get from somewhere, we have to get power, we have to get DC power. So in order to make the generator fully brushless, without brushes, we have to transfer this power somehow without brushes inside in the rotor. This is done by means of exciter or main exciter. Its windings are removed, these should be here. So these windings which are here of the primary exciter, these are armature windings. So these armature windings stays in this position. This winding, this is the field winding of the primary exciter. So the idea is as following. When we apply field current of DC, of course, field current here, then the magnetic field is created. Further, when we start to rotate this rotor, then this part will rotate inside in this magnetic field. So further, when we start to rotate armature in the magnetic field, we got an EMF. This EMF will be AC, alternating, But the field windings require DC. Therefore, we have this rectifier. So AC is supplied to the rotating rectifier. So actually these are just the diodes. So 6 diodes. So AC is applied to rectifier and we got DC. And this DC is supplied to the field winding of a main generator. These poles are also rotated. So these are rotating. And therefore magnetic field, which is created by these poles, it will start to rotate inside in the main generator stator. When this rotating field will rotate inside in the armature windings, we got an EMF in the armature windings. So this is the 3-phase armature windings of a main generator. Further, output from these armature winding can be supplied to terminals of a generator without making any without taking any brushes, any slip rings and so on. So this is another part of the armature winding here. So this generator becomes brushless. As you can see, we need at least 2 electrical machines to make it brushless. However, we have to take from somewhere field current to this primary exciter. In order to make this system fully self-contained, it's better to take this power from somewhere inside of the generator. To do this generator is equipped also with the pilot exciter. So the idea is as following. These are permanent magnets, yeah? 1 second and so on, yeah? So these are permanent magnets. So this is the permanent magnet generator, or PMG. When our generator starts to rotate, PMG's permanent magnet starts to rotate too, and they create magnetic field, and since these are rotating, then this magnetic field also will rotate. So this magnetic field will rotate inside in this part. So the EMF here starts to be generated. This is the armature winding of the pilot exciter. Further, this AC is removed from the generator, is sent to the voltage regulator. Then it is rectified and controlled. And controlled DC is supplied to the field winding of a primary exciter. And further, primary exciter generates AC. This AC is rectified and applied as a DC onto the field winding. This field winding generates magnetic field, and the generator, when it rotates, this magnetic field will also rotate, and we got EMF, so we got output voltage of the generator. So very great. So, what kinds of problems now we have? No? Of course, we have benefit is that we do not have any brushes, so we do not have to make any inspections. Yeah? This is really great. From other side, we need cooling, and we still have some ball bearings. Yeah? So cooling here is done by means of cooling air. So the cooling air is supplied from the back of the generator, goes through these windows, and further it goes inside through the generator, yeah, also through these windows to cool the rectifier, yeah. And further through the generator it goes outside from these windows, yeah. So these windows here, yeah. So the problem is that ball bearings still should to be of the sealed type, yeah. Here is the one ball bearing, and the second one ball bearing should be here. So the general limiting factor of the generator now is the ball bearing or ball bearings. In order to increase lifetime of the generator, these ball bearings on this generator has lubrication system, but this lubrication system is really very simple. Here's the plunger. This plunger can be removed, yeah, and can be filled with grease. So approximately 5-6 grams can be added there. Further, this grease comes into the ball bearing. So these 5, 6, 7 grams of grease is sufficient for approximately 1,000 flight hours. Further, we will have to re-lubricate this generator. So, partial solution, which extends the life of ball bearings. However, periodic lubrication still is required. So, how powerful is exactly this generator? This generator is 60 kilovolt amperes. Yeah, so it provides 40 kilovolt amperes. So it provides 40 kVA, yeah, and its speed of rotation is 6,000. It means that it has 8 poles or 4 pairs of poles. Yeah, 1, 2, 3, 4, and from the back, another 4 poles. Yeah, so 8 poles in total. Okay, so 6,000 RPMs. The weight of this, or mass of this generator, is approximately 40 kilos. It means that this generator provides 1 kilovolt ampere per 1 kilogram. Actually, this is not so good as we had in rotating field or in rotating armature generators. This happens because actually in this generator we have 3 machines, main generator as well as 2 additional generators. That's why its weight is approximately by 15 or even 20% greater than we can have in a rotating field or rotating armature generators. How we can overcome this weight problem? So actually mass has been increased compared to previous types of the generators. How we can overcome this problem? We can increase speed of a generator. In order to produce 400 Hz, the generator with 8 poles, 4 pairs of poles, should rotate with the speed of 6000 RPMs. If it would rotate with the speed of 8000 RPMs, then it will have only 6 poles, not 8, 6 poles. In this case, dimension of the rotor will be slightly smaller, therefore dimension of the stator also will be slightly smaller, and therefore mass reduction will occur. How much? It will be approximately 30 kilos per 40 kilovolt amperes. So it will give us 1.3 kilovolt ampere per 1 kilogram. So much more better, yeah? Do we are able to use only 4 poles in order to operate at the 12,000 RPMs? The answer is no. Why? The answer is the problem is in ball bearings. When we start to rotate them faster, then ball bearing starts to heat. Now this ball bearing has some free movement. However, when they start to heat, the ball starts to expand and they can be sized. They can stick. So this is the real problem. So we need to provide additional cooling for the ball bearings. In this air-cooled construction, it is not possible. Therefore, the maximum what we can get from the air-cooled brushless AC generator, this is the approximately 1.2–1.4 kilovolt amperes per 1 kilogram, and that's not more, unfortunately. And still we have to relubricate these bearings each 1,000–1,500 for 8 hours. So this is the end of the evolution of such generators with air cooling, and the next generators will be with oil cooling.